Hello everyone. Today I am showing you the coding of my MLP Kaggle assignment 1. So let's start. So first I have run this code which gives me the path of the files like test.csv and train.csv and sample submission.csv. Then I imported pandas as PD, and then I read the data by entering the paths of train.csv and test.csv and save it in train.df and test.df. Then I printed the data and see how it looks, and also I have printed the info of the data so that I get an overview of the data. So here is the data. First 5 rows of the train datasets, in which there are several columns, and then there is a info tab in which I see many information of the data, like how many null values are there and what is the data type of each column. And then also again we see the first 5 rows of test dataset. Then I printed the column data types to see what is the data types of the columns present in train df and test df. So for each column I have printed the data types, and also here I also done the describe method to see the descriptive statistic of the numerical columns. And also I have done the median of numerical columns of the train datasets. So here is the output column data types in train. So here is all the data types of the in the train dataset, and here is the column data type of test dataset. And then uh, here is the descriptive statistic or numerical columns of all the train dataset, like count, median, mean, standard deviation, 25th percentile, 50th percentile, 75th percentile, and maximum. Then here is the output of median values for numerical columns. It shows all the numerical columns median values. Then I then I have done then I have then I to understand the data set, uh, I have checked is there any missing values in the data set. So I have so with the function is null, I have checked is there any null value in the train data set or not, and if there is null value I will replace it with the median of the numerical column. Similarly, I have checked if there is any missing value in categorical columns, and if there is any missing values, I will drop the row, and then again I print if there is null value or not to check if the missing values will fill or not. So here we can see that there is some missing values in the size and total square feet and bath and balcony and price columns, balcony columns. Then I have dropped the categorical columns like location and size, and replace the missing values of numerical column with its median. Then to find to check if there is any duplicate rows in the data sets or not. So it's my luck that there is no duplicates in the dataset. So it's a good thing that there is no duplicate values. Then I imported the library called matplotlib to plot the dataset, and also the seaborn library to plot the dataset completely. And then I plotted the dataset with these things, and here is the output. I have plotted for price box plot, and for total square feet blocks plot and path block plot, to see if the data is concentrated at any one place or not. So here we can see that balcony value counts are this and this. Then for outliers, like there, here we can see that there is some outliers in the price box plot, also in the total square feet box plot, and also in the bath box plot. So to remove that thing, I have used the quantile method. So we used 99 percentile for each feature. Like for price, for square feet and bath feature, we use 99 percentile to exclude the outliers from our dataset, and store it into a new filter.train column. Then again we plotted the charts. So here we can see that the outliers is removed in each of the columns, in the price, square feet and bath column. Then we are doing some we are making some distributions to see if the data is how is the data is looking. We are doing some visualization for the data. So here is the visualization house price distribution. So here we can see that it is a right skewed data, and there is another visualization of total square feet and price, and it is here we can see that it is a growing type of data. Means if the square feet is increasing, then the price is also increasing. And here is the box plot of area type versus price. Now we are doing the encoding and the scaling methods. So from scikit-learn we have imported label encoder and standard scaler. So I have now copied the data into df. Then I encoded the categorical variables like area type and availability and location, size, etc., and imported into our dataset cat.columns. Then we have implemented the encoding. Then we have implemented the standard scaler on the numerical column and encoding on the categorical columns. Then finally this is our data after encoding and standard scaling. Then we have splitted our data into test and train set from scikit-learn model selection library. Then we have imported some models like linear regression, ridge regression, lasso, decision tree, random forest regressor, gradient boosting, k nearest neighbor SVR, and mean square error R2 score to check different models. So I have imported into a one single variable called models, and then we have checked for so many models like for linear regression, ridge, lasso, and so on, what is their root, mean square error, and what is their R2 score. Then we have compared. Then yes, now we are doing hyperparameter tuning for the dataset for 3 models: gradient boosting, random forest, and ridge regression. Then we are comparing all the models and checking what is the performance of all the models. Here is the whole output, in which I can see that grader boosting is doing the best, but in our analysis we are going with linear regression. So we fitted the data with linear regression. First we uh, created linear regression, then we fitted the data, then we predict the data, then created the final submission CSV file, and then I submitted it into the Kaggle submission portal. Thank you.